Yeah, before I started it. Yes. Yeah. Yeah. Morning all. So before I start, can anyone please confirm whether my voice is clear? Where the screen is visible, right? Yes. Fine. So in the last class, I was just briefing you about Spark. Spark is an open source. It's a distributed cluster computing framework with a parallel processor style, with in-memory computation feature, and for large use for large scale data process. Distributed cluster computing, right? Parallel process, data is distributed across multiple systems and data is processed by multiple systems parallelly. Okay. Used for large scale data processing. Spark can be coded with Python, Scala, Java, and R language. Mostly used programming languages are these two, right? Why PySpark, right? So it's a Python API to use Spark. It is a demanding tool among data engineers. It is used for running distributed SQL, creating data pipelines, placing data into data lines, running ML algorithms, working with graph algorithms, working with streaming. It is 100 times faster than normal disk processing. You see that databases have taken days of time. These specialized databases like Teradata and Etija have taken hours of time, where Hadoop has taken minutes of time, but Spark is 100 times faster than Hadoop. Already Hadoop has got very high speed, but still Spark is 100 times faster than that. Spark features in-memory computation, storage and processing happening within the memory level, lazy evolution, on-demand executing the flow. Persistence, already executed transformation output can be reused. Partitioning, Spark data is divided into partitions distributed across multiple systems. Powerful fault tolerant model. Even if any system goes down, it has got the capability of regaining the lost partition. Was introduced in the year 2009. It was open sourced in 2010. It was donated to Apache Software in the year 2013. Execution generations, Hadoop MapReduce, Tej and Spark. Tej and Spark both follows DAG model. Directed acyclic graph model. Tej doesn't follow in-memory computation. So Spark has got high speed over Tej. Another in-memory computing systems, right? Other in-memory computing systems. SAP HANA and Spark both are in-memory computing, but HANA is not distributed, but Spark is a distributed RAM. So mainly Spark is mainly designed for batch applications, iterative algorithms, interactive queries, streaming. Yes. Spark and we used to have a component called Apache Pick. Spark and Apache Pick. Both are data flow languages. Okay, before I go with Spark Pick, Spark and Hadoop MapReduce. Spark and Hadoop MapReduce, right? If I compare both, MapReduce drawbacks. Hadoop MapReduce drawbacks. Transformations cannot be reused out there. Every time we need to re-execute. Transformations cannot be reused. Transformations cannot be reused. Every time we need to re-execute from the beginning. Bad for iterative algorithms. Bad for iterative algorithms. Hmm. But Spark is good for iterative algorithms. Map reduce drawbacks if you say not a flexible parallel process. Not a flexible parallel process. Because map reduce, if we talk, mapper phase, reducer phase, two phases will be there. Until mapper phase executed, reducer phase cannot. Both cannot execute parallel. That's why we say not a flexible parallel process. Slow speed as compared with Spark. Hmm. Now Spark and Apache Pig, both are data flow languages. Both are data flow languages. But both are data flow languages, but in Pig. So Pig was see, before Spark was introduced, Apache Pig, it is one of the famous scripting language. It was mostly used, widely used in the industry. 100 lines of Java code we can write within 7 to 10 lines in Pig. That is what the simplicity of Pig. Very less coding, scripting we used to write. But when Spark was introduced, Apache Pig was outdated because both are data flows. But in Pig, the entire data flow is converted. But in Pig, entire data flow is converted into one MapReduce job. But MapReduce is bad. MR is bad. Previously, we have seen the drawbacks. So if you see many, if compared with Tej, compared with HANA, compared with Hadoop MapReduce, Spark compared with Pig, Spark compared with Flink, Spark and Flink. In the initial days, see here both are given by Apache software. Both are given by Apache. Both are given by Apache. Both. See, if you talk about this Spark and Flink, both objectives are same. Means purpose. In the initial days when Spark, when Spark was introduced, immediately after that, Flink also got introduced. But in the initial days, right, means if you go back 2016, 17, 18, when Spark was introduced, then they were saying that Flink was dominating Spark and Spark will be away from the market. Flink was dominating, yes, Flink was dominating Spark. Yes, in the initial versions, right? In the initial versions of Spark, it was little weaker. It was little weaker. In terms of analytics. See, before Spark 1.6 version, before Spark 1.6 version, Spark was weaker as compared to Flink. From Spark 1.6 version. From Spark 1.6 version, right? Spark was so Spark came with a powerful libraries from Spark 1.6. So it almost is equal to Flink, but from Spark 2 version onwards, totally Spark dominated Flink. That's why you're not hearing the name Spark Flink now. Hmm. Was weaker as compared to with Flink in the initial versions, but Spark came up with powerful libraries, right? So it was equal to Flink, but later in from Spark 2 version onwards, it dominated Flink. Now, based on the comparisons, right? Now try to say the Spark features and advantages. Spark features and advantages. Hmm. As compared with the Tej, it is an in-memory computing system. Both are DAG model, but a Spark is in memory because of its high speed. As compared with HANA, both are in memory, but distributed. Spark is distributed. Hmm. Next, as compared with MapReduce, transformations can be reused. Transformations can be reused. Good for iterative algorithms. Hmm. The flexible parallel process. Flexible parallel process. Very high speed processing. Parallel process. Hmm. Supports advanced analytics. Lazy evolution. Persistence. Already executed transformation output can be reused. Yes. Transformations can be reused. Means what do you mean by transformations can be reused, and what do you mean by persistence? What do you mean by persistence? Now, just I'll show you one example, right? Yes. Initially, the Spark data objects, we call them as RTDs. RDDs. Initially, we have got RTDs. We call it resilient distributed data sets, we used to say. Data sets. What are these RTDs? Resilient distributed data sets. Resilient distributed data sets, right? Yes. Spark data objects. Spark data objects, we call them as RTDs. RTDs. These RTDs again subdivided. These RTDs. These RTDs are again subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes. Slave nodes means system. These partitions are distributed across multiple RAMs of multiple slave nodes. This is Spark data objects we call like RTD. RTD programming style. Programming style is data flow. Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. A pipe is any data operation. A pipe is any data operation. Such as a pipe is any data operation such as loading data, filtering data, transforming data, merging data, grouping data, loading, filtering, transforming, merging, grouping, etc. In Spark, a data flow is executed. A data flow in sequence. In Spark, a data flow is executed in sequence. That is RTD by RTD. In a Spark, data flow is executed in sequence RTD by RTD one after the other because the output of one RTD will be the input to the next one. And that is in sequence, that is RTD by RTD one after the another with in-memory computing feature and persistence feature. Data flow is executed in sequence RTD by RTD with in-memory computing feature and persistence feature. If the RTD divided into 40 partitions, these 40 partitions can execute parallelly. These 40 partitions can execute parallelly. These 40 partitions stored across 40 systems and are executed parallelly. So you need to understand two things here. The importance of persistence in Python. We can check here, right? Persistence. What do you mean by persistence? Generally, just observe here. R1 and RTD1. How this RTD1 is getting generated? How this RTD1 is getting generated? If you load if you load any file, here the file path using Spark context, RTD1 is created. On this RTD1, I'll perform some filter operation. Filter city equal to the output whatever you get from RTD1 is nothing but RTD2. Again on RTD2, if you perform any operation, map operation, mapping each employee salary 5,000. You're mapping each employee salary by adding 5,000. RTD3 is created. Again, RTD3 dot group by you are saying. RTD4 is created. Then on RTD4, you can perform something, some transformation. RTD5 is created. So in this way, how an RTD, the output of one will be the input to the next. Output of one will be the input of the next. So here first from a file, RTD1 gets created. RTD1 output will be the input to the next RTD. Directed acyclic graph model, not a cyclic model, acyclic graph model. From RTD2 again, RTD2 output is taken as input by RTD3. RTD3. This way, RTD3 output is taken as input by RTD4. RTD3 output is taken as input by RTD4. Finally, this RTD4 output will be collected. So just check it here, and here I got some couple of queries. Here RTD1, RTD2, RTD3, 4, 5. In this way, multiple RTDs. Yes. So yes. RTDs means data Spark data objects. Data frames will be having schema. RTDs doesn't have schema. That is the difference. The Spark basic data objects are called as RTDs, but with structured and with everything we are going to store in data frames. So before you go with the data frames, you need to have some little knowledge on this RTD. Before you go with the data frames means structured like rows and columns. You will be having clarity about what is that. But before that, data frames, you need to know something about RTD. RTD, the output of one will be the input to the next, the output of one will be the input to the next. Think that you got 30 RTDs. Where these 30 RTDs are stored? Where this, everyone try to unmute and try to respond, right? Yes, whether your answers are correct or wrong, keep responding.
Spark.
Where these RTDs are will be stored?
No, until actions are performed, RDD will not be executed, right?
Yes, yes. So for example, on this RTD4, I'm performing action. On this RTD, I'm performing RTD4 dot action. Then it executes one by one RTDs. Think that you got 40 RTDs. Now on the RTD 40, I'm performing action. Now they'll be executed. Now where the RTDs will be stored? 40 RTDs, where they get stored?
Master node.
See, one thing, master node just maintains the data information, file information. Slave nodes, see, single master, in this way, this is your master. In this way, you will have slaves. You are going to have slaves. So your data will be distributed across these multiple slave machines. Data will be distributed across multiple systems. Data is stored by multiple systems. Data is processed by multiple systems parallelly. So your data is stored across slave systems. So here I'm asking, in Spark data is stored into the, for example, Spark data will be stored across multiple systems in RAM1, in RAM2, RAM3, and RAM4 only. In the RAMs only it is going to get stored. Generally, it is going to store across multiple RAMs. Okay, here my query is, if you have got a very big data flow, assume this RTD1, the size is like 5 TB. Generally, we use for huge data only we are going for this Spark, right? Spark or PySpark is used for huge data processing. So if you got RTD1 size is 5 TB, in this way, like this RTD1, we have got 40 RTDs, 40 into 5 TB. So this 40 RTDs, where they are getting stored and how they are stored and how they are computed. Means Spark data, that RTDs, initially we solve Spark data or RTDs, they are stored within the RAM memory level, they are processed within the memory level. So 40 RTDs cannot be accommodated by the RAM. 40 RTDs means one RTD size is 5 TB you are taking. That much, okay, for one RTD or two RTDs, it's fine. But for 40 RTDs, the space cannot be accommodated by the RAM. Those many RTDs cannot fit into the RAM. So how they are going to get executed means, check this. Resilient distributed data sets. See, just try to understand. RTD1 or R1, I'm saying. First, it gets loaded. First, it will be divided into partitions. It's a big data object divided into partitions. All these partitions, P1, P2, P3, P4. This stored across system 1, system 2, system 3, system 4. And they'll be parallelly processed, executed. This R1 output, whatever you are going to get, will be stored by R2. Will be stored by R2. When R2 is loaded, R2, this output means from R1 only R2 is generated. From R2 is, whenever this R2 is loaded, computed, all this R1 and its partitions are going to be removed from the RAM. Now R2 is there. Now R2 after loading computed, now the output of R2 is taken by R3. Means the output of R2 is taken as input by R3. Now check this, when R3 is loaded and computed, R2 gets removed from the RAM and its partitions. Now R3. Output, this is the input. Here R4 we see. When R4 is loaded, computed, R3 and its partition gets removed from the RAM. And finally, when R4, when this is loaded and computed, this gets removed. Finally, this R5 output will be collected by the client. The final which one that this output will be collected, right?
Here entire data stored in the one RD file, right?
One second. I'll come back to your queries. First, try to understand this flow. Once the total execution, total data, once the total output is collected, R5 is going to get removed from the RAM. Once the total right output is collected, R5 also removed from the RAM. Understand carefully. At the starting, there was no RTDs in the RAM, but when you trigger the first flow, one by one RTDs, they are going to get loaded and going to get removed. One by one, they get loaded. Once this output is collected, this final RTD also removed from the RAM. Now try to answer how many RTDs in the RAM now after the flow execution is completed.
No RD.
No, now you can trigger the second flow. Now you can trigger the second flow. Another flow. In the another flow also, one by one, they gets loaded, computed, and gets removed. They gets removed. That's why RTD by RTD. So that's why two RTDs you cannot execute parallelly, because first RTD output, the first RTD execution completed, its output has to be given to the second RTD, then second RTD can compute. Until then, 10 RTDs are there. All the 10 you cannot load at a time. All the 10 you cannot execute at a time. One by one, they get loaded. One by one, they execute. The output will be given to the next one, next one, next one. You want to understand? Yes. Someone asking.
Yeah, sir, I just have one question.
Mm.
Uh, so this is regarding a one context, like a Spark context. So if let's say a client one who has created a one Spark context, and in that context he has running or processing these RDDs. Okay, so for these particular client in that particular Spark context, these RDDs are running one by one. Okay, but if there are two clients, then there will be a Spark context for that. So in each Spark context, can RDDs run parallelly or not like that?
See, you're talking two different flows, two different clients. They're submitting two different jobs.
Yeah, exactly.
Two different clients. They're submitting two different jobs. The two different jobs will be executed parallel. They will be keep going parallelly.
Okay, okay. So in that case, there will be a partition
If,
in the RAMs
for
ac-
example,
according to a
for
Spark context
example,
or what?
for example, in the job one, this data P1, P2, P3, P4, P5 is involved in job one. Second job is whenever it is submitted, you will be having different partitions, right? Yeah, the data will have, okay. Here also, the data is divided into, think that it is some name, Q1, Q2, Q3 I'm taking. It is also divided into 5 partitions, 5 or 5. This will be stored in system 1, system 2, system 3, system 4, system 5. System 5 means 5 systems, they are storing 5 partitions of job 1 and job 2. Means in a system partition, the single partition means in a single system you can store any number of partitions. So job 1, job 2, there is no they are running independently. They are running job 1 and job 2, they are independent. there is this both the flows. This is one flow, this is one flow, two data flows, two independent data flows. They can run, they can execute parallelly. There is no dependency between these flows.
Okay, so in this case, we will have a two Spark context, and in that particular context, each job are running separately, right?
Yeah, two jobs can run parallelly. They are separately. They are executed independently. There is no dependency between those two.
Okay, okay.
But okay, for example, now I'll come to your same query only. But if the flow is in this way, try to observe. Um, this is the first data object. From this data object, R2, R3. If it is in this way, R4. This is one flow. This is one flow. Second flow is like this. Second flow. This is flow one. Understand, this is what? Flow one. Flow one or everything. This is flow two. This is flow two. Flow two. So from up to first three, they are common in flow one and flow two. From there onwards, they are going differently. Observe this flow three now. Three different flows. R1, R2, R3. Again from there, R6, R9. Three different flows. This is flow three. This is flow three. Flow one, flow two, and flow three. Observe this and everyone try to respond for this. In flow one, what are the R1 to R2 to R3 to R4 to R7? Flow two, R1 to R2 to R3 to R5 to R8. Flow three, R1 to R2 to R3 to R6 to R9. Three flows are there. First, I want to execute flow one. Flow one you want to execute. Check it. Later, I'll execute flow two. Later, flow three. If I'm executing, okay. First, I'm executing flow one. I'm not, for example, I'm not executing at a time, one after, for example, one after the other, I'm executing. Assume. Here, first, if I want to execute a data flow, what I said? Lazy evolution. Lazy evolution means they won't execute until you make some kind of action. So I need to perform action on what to execute the flow one? R1, R2, R3, R4, R7. R7 dot action I need to perform. Means from here, now whenever you perform action on this R7, it starts from its root R1 onwards to R7 and so first R1 loads, computes, its output is given to R2, R2 loads and computes. Now R1 gets removed from the RAM. Next, its R2 output will be given to R3. So loads and computes, R2 gets removed. Now R3 loaded, R4 loaded, it's computed, R3 gets removed. And similarly, finally, R7, right? Loads, computes, R4 gets removed. Now total output is collected. Now this also gets removed. Now no RTD in the RAM. No RTD in the RAM, right? Now you will trigger the second flow and you will try to say FR8 dot action on the last RTD PQ. Again, the flow starts from R1, R2, R3. See the flow to R1, R2, R3, R5, R8. Once these are ready, the output of this is given as input to the next flow. Once this is ready, this gets removed. When this is ready, it gets removed. When this is ready, it gets removed. And finally, when the output is collected, this also got removed. In the flow 3 also same thing, R1, R2, R3, R6, R9. So when this is ready, the previous one gets ready. This is ready, the previous one gets removed when this is ready. In this way, same thing. When the last this one R9 is once the output is collected, it gets removed from the RAM. So now in the first flow, there are no RTD. Second flow also, once the output is collected, no RTD in the RAM. Here also no RTD. You executed 3 flows. But what is the drawback in these 3 flows? What is the drawback in the 3 flows?
We are executing the same things. Still
Hmm.
R1 to R3.
Yes, exactly right. What is the drawback in these 3 flows means? Even though the first 3 steps are common in each and every flow, again, okay, in the first flow you executed R1, R2, R3. Again, in the second flow, again you are re-executing R1, R2, R3, right?
We can't because of already deleted now.
So in the second flow, again you are re-executing R1, R2, R3. So what I said, the advantage of Spark, check it in this, the advantage of Spark, if you see in this persistence. What do you mean by persistence? Already executed transformation output can be reused by the next flow. Already executed output, already executed transformation output can be reused. That is what persistence. But here, again, here we have taken a small flow. Think that if you have got some 70 RTDs, in that first 40 steps are same. First 40 steps are same. Here 3 steps only are same, right? Think that first 40 steps are same. Means in the second flow, again, you are re-executing the 40 steps. In the third flow, also re-executing the 40 steps. So here the drawback here is you are re-executing the first 3 steps. So to overcome this in Spark is give persistence. We have got persistence option. We have got persistence option, right? So persistence option means right.
Here I have one doubt. If we execute it parallelly, that time also we can't able to reuse that, right?
Okay, 1 second. Forget about, okay, first we see flow 1, flow 2, flow 3. One after the other you executed. I'll come back if you are executing parallel. Now, 1 second.
Sir, this is a concurrent, right? Not a parallel.
Not parallel.
Yeah, this is a concurrent one.
Flow 1, flow 2, flow 3, they are executed one after the another.
Yeah,
One
so
after one flow one after the other. Because 1 second. Now come back to the same flow. This is my flow. What I have taken R1, R2, R3, R3. This was like R4, R4, R5, R6. R7, R8, R9. This was your first flow. This is second flow. This is your second flow. And this is your third flow. Flow 1, flow 2, and flow 3. Now, generally, you are re-executing the first 3 steps. So, we will be persistence means we are going to persist the one whose output is commonly used by multiple flows. The one whose output is commonly means this R3 output is used by up to R3, okay. But from there onwards, multiple flows you got, its output is used by multiple flows. So you will persist. You will say R3 dot persist. Persist means making this available in the RAM even though the next one is ready. Making this object available in the RAM even though the next flow, right? The next RTD. Oh, now I'll execute this flow 1. Now try to say flow 1 execution means I need to say R7 dot action. R7 dot action means, okay, I need to start from R1. R1 loads R2, R3, R4, R7. So this is ready. These partitions and this everything gets removed from the RAM. This is going. But when R4 is ready, R3 is not going to get removed because it is persisted. It won't be removed from the RAM even though the next one is ready. Now, when R7 is ready, R4 gets removed. Once the total output is collected, right? This is also getting removed. Now, which is available in the RAM? R3 available in the RAM now. R3 available in the RAM. Now, once the flow 1 executed, in the flow 2, you can reuse already executed transformation output. No need to re-execute from the beginning because this R3 is available to view its output to the. Okay, now check it. If I say R8 dot action, if I say R8 dot action, R8 dot action, if I say, it will immediately check, okay, R8 output you are expecting. It will check first. From where I need to start the flow. Where I need to start the flow. R8 input is R5. Is R5 available in the RAM? Is R5 available in the RAM?
Yes.
No. No RTDs in the RAM. Only R3 is available. No other RTDs are available. R5 input is R3. R3 available. R3 available. So flow is R3, R5, R8. Means we don't need to re-execute from the beginning now. R3 is available in the RAM. R3 is ready to view its output. So R3 output is given to R5. Now R5 and R8 are going to get computed. Only you R5 and R5 you are computing this time. The first three steps you are not executing. When R5 is ready, R3 not removed. When R8 is ready, this is going to get removed. Once the output is collected, this is also going to get removed. Now still R3 available in the RAM. Means we have reused the already executed transformation output. I'm talking about if you are parallelly if you are submitting, I'm talking already executed transformation output is reused here. R3 output is reused. And no need to execute R1, R2, R3. Similarly, for the flow 3 also, right? For the flow 3 also, R9 dot action you say, R9 dot action you say. Now it will check, okay, first it will check R9 input from where I need to get that input for R9.
R6.
Which one? R6. Is it available?
No.
No. Again, it will check R6 input from where I need to get.
R3.
R3, is it available?
Yes.
R3 available right now, as we have persisted, right? So the one which is mostly used, that RTD will persist. Now the flow is R3 is ready to give its output to R6. R6 to
R9.
R9. So this will be there. Once this is ready, R3 won't be removed, but when R9 is ready, R6 removed. When R9 output is collected, this also removed. So in all the three cases, R3 is available in the RAM. R3 is available in the RAM. Means here in the flow 2, flow 3 already, it's not re-executing, reusing. It's not re-executing from the beginning, it is reusing already executed transformation output. Think that if there is a big data flow, right, of 70 RTDs, in that first 40 steps are free. Means from flow 2 and flow 3, what they can do, they can reuse the R40 output in a computer. The first 40 steps decreased. We are reusing. Okay. Now R3 is in the RAM. Yes.
So just one question here. Now we are persisting R3, okay? So let's say if R3 is of 5 TB, okay? Like RDD is of 5 TB. So in the RAM, this R3 is getting persisted. It means it has 5 TB already stored with respect to the R3. And if the next RDD is getting executed, then again the 5 TB data is again processed for the next RDD. So in this case, it will have a 10 TB of data at the same time, or it is caching is in the different disk, like not RAM, like ROM or anywhere else.
So 1 second. So here I've got multiple persist options are there. Memory only option is there, disk only option is there, memory and disk option is there, right? So if memory is full, right? So instead of the execution getting failed, we'll give memory and disk option. If memory is filled, just persist in the disk. Once the memory is free, again get back to memory. That is what memory and different persist options are there. Memory option, disk option, memory and disk option. Some there, even though if it is a very big one, it cannot be loaded into RAM. In that you can also go with a disk and memory and disk also there. Later I'll be discussing about these different options, right, in persistence and memory, disk and memory and disk. Instead of execution failing, instead of job getting failed, you can also persist within the disk level when the memory is not available.
Okay, so if we are storing R3 in memory, like in the RAM itself, and when the next RDD is getting executed, so the performance of the next RDD execution will get little bit lower, or we will get the 5 TB like previously. If the R3 RDD 3's output we are getting in the 5 minutes, and now we are persisting the RDD in the same RAM itself, and now we are executing the R4 RDD.
See, generally, 1 second.
So the
So
performance.
performance is increased here because in the second flow, in the third flow, you are already that R3 is available, right? So, for example, many steps are getting decreased, right?
Yeah, no, I mean R4
Okay, you
execution
are you are
time.
talking you are talking about the performance, right? So here
Uh,
I have taken a small flow, but if you are taking a very big flow, it is decreasing n number of steps, right?
yeah, yeah. No, I'm talking about the next R4 execution time will get lower or will be a same when, even though the R3 is stored in the same RAM.
So generally, at least for persisting. So if you have got to see one thing in the next in the coming sessions, I'll be providing examples, right? Single RTD you are persisting here. If you have good RAM capacity, right, you can be able to even persist multiple RAMs. Means depending upon
Okay.
your RAM capacity, you are going to persist it. Means even one RAM you have one RTD you have persisted here. But if there is a chance where there is one more RTD, can you persist? You can also persist it. Multiple RAMs can be persisted. It all depends upon your memory. If you have got a good memory, you can also persist multiple RAMs also. Here only one RTD I have persisted, but even you can also persist multiple RTD. So next here R3 output is used by multiple flows. Later R8 output is used by multiple flows. Then R8 also you can persist. So that in tomorrow, like any flow is using directly from R8, it can start.
Okay.
Means if you have got good RAM, if you have got good memory only, you can pass. Otherwise, the next upcoming RTDs, they cannot be loaded into RAM again, as you said. So if you have got a good RAM, good memory, means then only you can go with these things.
Okay. Okay. Yeah, sure.
And
Thanks.
that too, it is distributed RAM, right? That too, it is distributed RAM, all the multiple systems. Okay? Yes. And here, if you observe, if I go back to the previous example, in flow 1, R3 is there, in flow 2, in flow 3. Now R3 is available in the RAM. Now all my all my jobs got executed, all my flows, all data flows got executed. Now everything got executed. Now still R3 is in the RAM. Now I doesn't want R3. My work is done. Okay. Now what you will do? Forcefully you will unpersist it. R3 dot unpersist. R3 dot unpersist means immediately it gets removed from the RAM. Immediately this R3 gets removed. Unpersistence happens immediately. Persistence won't happen immediately. Understand what I'm saying? Unpersist happens immediately. Immediately it will go and remove R3 from the RAM. But why persistence won't happen immediately? Why persist? For example, I want to persist R9. I want to persist R9. Immediately I cannot go to R9 and persist it. First R1 has to be loaded, R2 has to be loaded. It has to come to R9. Now R9 gets persisted. During this, now it will be persisted. Means until R8 output should be taken by R9. R9 should load into the RAM. R9 should load into the RAM first. After R9 getting loaded, it will persist it. When the next one R10 is ready, R9 won't be removed from the RAM. Means persistence, when it happens, means whenever it is first time loaded into the RAM, then only it will persist it. Means when the time comes during the flow execution, R1, R2, R3, or when it comes to R9, already you have given instruction to persist R9. Now it will persist it. During the flow execution, only it can persist. But unpersist, immediately it will remove unpersistence, right? So for this persist, this is one of the important feature of Spark. We see persistence, so that already executed transformation, but already we have got other like big data Hadoop is there. In the transformations, you cannot reuse. Always you need to re-execute from the beginning again and again. So here transformations can be reused. Persist is one of the important feature of Spark, and in-memory is one of the important feature of Spark. Yes. And many persistence options are there where you can persist it, right? How it persisted, and also some rules are there to be. Some rules we need to follow for persistence. See, if you want to make use of already executed transformation, at least one flow has to be executed already. One flow should be already executed, then only RT should have been persisted. If no flow executed means no RT is persisted. You cannot make use of that transformation output. If these three flows, just now someone asked if the three flows are submitted parallelly, this can you reuse this R3 output? No, R3 output can't be reused here when they are parallelly they are executed. Means when you are parallelly executing, all will start from R1, 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 because don't think flow 2 will start from R3, because still R3 output, R3 is not computed in the flow 1. In the flow 1, still R3 is not computed, still it is not persisted, still it is executing R1, R2. So flow 2 and flow 3, they cannot start from R3 until this R3 is persisted. So the flow will start from the beginning for all these three if you are submitting parallelly. When if you are executing one after the other, already in the flow 1, there should be some RTDs getting persisted. From there onwards, you can execute the flow for the flow 2 and flow 3. Okay, fine. Okay, you can check with this, right? 1 second. So we have got a lot of discussion on this. You need to understand this before we go with the data frames, right? Okay. So you'll be getting all these session videos, notes, everything. I'll be forwarding you the clear notes. I'll be forwarding. So from tomorrow, right, the link will be changed. The link is going to be changed. The people who have already enrolled, you'll be getting the link directly to your mail. That online team will forward the link directly. With who didn't enroll, right, try to get enrolled for getting the videos, notes, and the links for the tomorrow's class. Tomorrow a WhatsApp group will be created. You will be added to the WhatsApp group where you can have direct interaction with me. A separate WhatsApp group for this. And tomorrow tomorrow onwards you'll be getting the videos daily to your Google Drive, right? Yes.
If you have any questions can I talk in Telugu? Or if I can understand.
Yes, you can ask.
Oh.
Any query, anything you can ask during the session. You can unmute then and there only. No need to wait up to the end of the session. Immediately you can ask. I'll provide multiple examples, right?
Yeah.
So all the sessions are interactive. In the practicals also, what I am asking you, do parallelly along with me the practicals also. Okay, fine. And videos will be getting soft copy of the notes. And it's a WhatsApp group. And just observe this course content once. You can see a message is given by the online team. Their contact details they are provided. Yes, the payment details they are provided, right? and the payment details, their contact details, and the course content details, everything they have posted, right? Now, just observe this course content. So both the Databricks and PySpark in brief. See, this is, I'll be giving knowledge on this big data Hadoop also before I go with the Spark. And this creating Azure Databricks service, displaying cluster, starting a cluster, terminating a cluster, deleting cluster logs. So here we have the total control on the cluster. Yes, 3 types of cluster. We'll create the cluster, how much cluster capacity, what, so different type, which cluster, when to execute, when to go with which cluster. Databricks pool, cluster modes, Databricks different types of utilities, integration with different storages, PySpark data frame, right? Yes, creating data frames from different object, from different things, right? From CSV file, from JSON file, from databases, different functions, Spark SQL functions, Spark built-in functions. In order to write huge codings, we can make use of all these functionalities with many working examples, and also working with different file formats, CSV, JSON, Parquet, Excel, XML, ORC, Databricks batch processing, PySpark external sources, Databricks streaming API, Databricks Lakehouse, and workflows in Databricks. So if your people who have got enrolled, don't forget to share the screenshot of your payment to that mail ID that is provided. Then only they forward the link to you to the same mail ID. With what screenshot you with which Gmail you are forwarding that screenshot to the same mail, they'll be forwarding you the link, right? Most of you will be facing issue with the link saying that you didn't get the link. So you are supposed to share the screenshot of your payment to that mail ID that is provided there, right? Yes. Then only, okay, fine. Any other queries you have got, anyone, right? All the sessions will be interactive sessions, right?
Yeah, during the some classes we need to do like we are creating any project, mini projects. The focus.
What is that? During?
Yeah, during the for example, we have done of 1 month. After we have doing any mini projects like
Yes. So I'll be showing you one floor, right? Project flow I'll be showing you, I'll be discussing, right? At the end. Yes. Okay.
after I have done this course, I have knowledge complete development on the PySpark.
Yes, yes, you'll be getting in brief in total command on this PySpark.
Yeah.
So everything from the basic onwards, the ground level onwards, not immediately going into the coding directly. So first, what are the, to understand the coding part, what are the prerequisites, everything I'll discuss. Next, we'll go with this. Once we start with the practicals, there won't be any theory like that. But the first initial sessions, you need to know something about how the computation is happening. What do you mean? Some technical terms you need to understand, like persistence, lazy evolution, how the computation in Spark is going to happen. So fault tolerance, what do you mean by fault tolerance? Everything that I'll be briefing you. But once we start with the practical, we can just go with that, right? And
Uh,
even yes.
yeah, just one question. Is there any doubt sessions we are conducting like at the weekends or on the Fridays or uh,
No, no, no. 1 second. If you have got any doubt, any query in the session itself, immediately you can ask. No need to
okay,
wait. No need to wait until that one of particular day like Friday. No. Within the class, immediately like interaction, right? You can ask any doubt, any query immediately. You can unmute and you can ask.
okay.
Okay, fine. That's what I'm saying. Even if you're doing parallelly, right, along with me, you can share the screen if you get any error in, right? You should be able to see because there are a lot of configurations we'll be doing, right? So compatibility issues will be there, version issues will be there. So that's why if any errors, immediately you can say and you can share the screen. I'll rectify why that errors are occurred. You need to know why that errors are occurring also, how to rectify this. Fine. Otherwise, you can also take the snap of the error and post in the WhatsApp group. Anybody can answer. I'll be answering. Fine. Okay.
Okay. And try to complete this course within the time period.
Yes. Okay.
Thank you.
And tomorrow also same time, right, sir?
Daily it will be same time 8 to 9. There won't be change in the timing, but link will be changed. Check that you got the link. Take that contact details of the online team. Today by evening 7 o'clock, by 6 or 7 o'clock, you need to get that link. If you're not getting, you can just give a call on that number, on that numbers that are provided, right?
Is it
Yeah.
possible to move 10 minutes before or not?
Exact-
7:50, that type of, because of
Exactly.
after we need to ready to office.
Uh, exactly at 8 o'clock, we'll start it and we'll stop. Okay. If you miss anything like 10 minutes, you can just go to the recording that 10 minutes.
Okay.
The day recording by the within 3 hours time, you will get the recording, right? Now, when the class gets completed 9 o'clock, by 12:30 every day, by 12:30, you will get that video of it. If you're missing anything last 10-15 minutes, right, because of some office time, you can just go to the recording. If you any query, you can ask in the next class.
Yeah, sure.
Yes, everything will be discussed. Everything will be discussed in brief, right? You won't be getting any kind of queries. Everything will be. If anything, any line also, just I'll be make you understand step by step. Okay. So even if people who doesn't have knowledge on this basic Python also, the Python videos will be forwarded to you once you get enrolled, like 30 to 40 videos of Python, right? Python, basic Python videos that is required, how much knowledge required, that videos will be given. You can go through, because initially first I'll be discussing with the Databricks, that architecture and the configurations, everything. By the time I will come to PySpark coding, right? You can just go to the recordings of Python. Okay, fine. So I'm stopping for now. We'll continue tomorrow, same time at 8 o'clock. Yes.
Yeah, thank you.